Okay, for these problems, we're asked to find the domain and range given a graph of a relation. So again, keep in mind the graph is just a pictorial representation of the relation. Each point is associated with an input-output. So just for example, on this last graph, it has the graph passes through the point 6, 8. So remember, 6 would be an element of the domain, 8 would be an element of the range. Okay. We don't want to write out all the ordered pairs, so how do we figure out the domain and range for these problems? Starting up at the top, can keep in mind domain are the x values. So you could imagine moving your pencil across and just saying where are all the x values. We don't care how high or low, that's a y value. We don't care how high or low it goes. Just as we move across the x-axis, which x numbers, which x values are part of the graph. So clearly back here at -6, there is no graph. We don't start picking up the graph until we hit -3. And again, I don't care how high or low the graph is. I just see there is a graph there. There's a graph at -2 at x equal to 0, 2, all the way to 3, and then there is no graph. Okay, so again, you're imagining walking along the x-axis. And as you move along, the graph starts here, and then there's a graph for all of these x values until here. And then there's no more graph. So the domain for this first graph would be from -3 to 3. Remember, we use brackets because the endpoints are included. For range, again, you would move vertically. Range are the y's or the outputs. So again, you imagine the y values that get hit as you move up from negative y's through y equals 0 up through y equals 6 and beyond. So again, you can see from this one, there's no graph down here. The graph doesn't start until you get up to y equals -6. There would be a graph at y equals -2, at 0, y equal to 4, and so on, up to 6, and then no more. So again, as you walk up, there's no graph down here, but starting with y equal to -6, all the way up to y equal to 6, there's a graph. After that, there is no graph. So our range for this one would be from -6 to 6. For the second one, for part B here, again, keep in mind in general, when we have graphs that look like this, we will assume that the ends continue. So we don't have the whole picture, but we can certainly understand that as we go further to the right, the graph keeps going up. As we go left here, the graph also keeps going up. Okay, so again, for domain, you're moving left to right because you're looking at these x values. And is there a graph? Well, clearly there's a graph here. So a little bit maybe a question is if there's a graph back here. Well, again, we assume the end continues up and to the left. So even way back here, maybe at -4, -5, -6, the graph would continue up and you would get a point up there. So all of these points would have a graph. Even when you go past 4, 5, or 6, the graph might be up very far and it's not, we don't see it, but we can again understand that the graph keeps going up. So all the x values are in the domain. So remember that's from -infinity to infinity. Okay. For the range, again, you're moving along y. So you find the y values for where a graph exists. Well, clearly down here there is no graph. Okay. So not until we get to about right here, which is at x equal to -3, then the graph starts. And then as we move up, there is a graph all the way up forever. Again, the ends keep going up, so as high as we want to go on the y-axis, there will be a graph. So our range here starts at -3, but then continues up towards infinity. And then the last one is a piecewise function. We see a few more of these in chapter 2. It's not unusual, but we don't see them that often as we move on. Same idea, domain and range. So domain, you're walking along the x-axis, you're moving from left to right and trying to find the x values for which the function exists or for which the graph exists. So again, back here, there's clearly no graph. The graph doesn't start until you get to x equal to -4. Then it continues, there's a graph until x equal to 2, and then notice the graph disappears for a while. So this domain has 2 pieces, which is not surprising for a piecewise function. So again, first from -4 to 2. So when we traveled from here to here, and again, keep in mind, I'm tracing along here because I'm looking for the x values. I don't care how high up and down it goes. I'm just looking from -4 to 2. There's always a graph. There's no graph between 2 and 4. And then the graph again picks up from between 4 and 6. Now notice this is an open circle here. So that'll be a parentheses up to here, the 6. So union 4, 6. Again, the endpoint 6 is included because there is a point at x equal to 6. There is no point at x equal to negative 4. Again, range, you're moving up the y-axis. So again, down here there's no graph. The graph doesn't start until we get up to negative 6. Notice that will be at parentheses, negative 6. As we move up, there is a graph. There is a graph. Even up here there's a graph. There actually is a graph to our left and our right, which is fine. Okay. We move up to here, there's still graph. Here there's still graph. Even when we get up to, let's say, 5, there's a graph. It's just the one out here. This one ended, but that's okay. So we can go all the way up. There's always a graph until we get up here at 8. And again, the endpoint here would be included because that endpoint is included.